A very good morning. Starting with the chapter 1, revision of the chapter 1, we'll be seeing a summary sort of thing. What is the motion of an object? We had seen this. We'll be continuing with the speed formula. Speed is equals to total distance traveled upon time required. The distance traveled in a particular direction by an object in unit time is called its velocity. Your unit time can be 1 second, 1 minute, or 1 hour. Moving with velocity is equals to displacement upon time. The displacement that occurs in unit time is called its velocity. Then we had seen some examples, we had solved them in now we had seen the uniform and non-uniform linear motion. We have seen what is acceleration. Acceleration is equals to change in velocity. The rate of change of velocity is called its acceleration. Now and then we had seen about what is initial velocity and what is the final velocity. Initial velocity is designated as by u, and initial final velocity is designated by v. Whereas what is positive, negative, and zero acceleration? An object can have positive or negative acceleration. When the velocity of an object increases, the acceleration is positive. In this case, the acceleration is in the direction of velocity. When the velocity of an object decreases with time, it has negative acceleration. Negative acceleration is also called deceleration. And then we had seen the time graph for uniform motion, and then distance time graph for non-uniform motion as well, velocity time graph for velocity time graph for uniform acceleration. We had seen and solved even this when we have studied the chapter in full. Equations for motion using the graphical method, we have derived them. V is equals to u plus at. This is the relation between velocity and time, whereas v is final velocity, u is initial velocity, a is acceleration, t is time, and s is displacement. The first equation, v is equals to u plus at, is the relation between velocity and time. Displacement is equals to initial velocity into time plus half of acceleration into t square. This is the relation between displacement upon and time. V square is equals to u square plus 2as. This is the relation between the displacement and velocity. And then we have derived them. We have derived these three equations with the help of some figures. We have solved them in detail when we have studied the chapter. This is just a revision sort of thing for you all, so that you will be clear in your mind at what you have to remember. Then we have seen about the uniform circular motion, and then we had taken an example of clock. As a tip is moving along a circular path in it, its motion is called uniform circular motion. Continuing with Newton's law of motion, Newton's first law says is about the balanced and unbalanced force. An object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. What is Newton's second law of motion? Newton's second law of motion is related to momentum. And what is momentum? Momentum is the product of mass and velocity of an object. P is equals to mv. Momentum is a vector quantity. The rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of force. Moving with the third law of motion of the Newton, every action force has an equal and opposite reaction which acts simultaneously. Moving with the law of conservation, the magnitude of total final momentum is equal to the magnitude of the total initial momentum. When no external force acts on two interacting objects, the total momentum remains constant. It does not change. When two objects collide, the total momentum before collision is equal to the total momentum after collision. This is where we end with the chapter. I hope this is useful for you all. This was just this summary sort of thing for you all. Thank you.